Functions. Okay, there's two things you need to know about functions. Okay, there's an independent variable and a dependent variable. The independent variable are values that are chosen, okay, and that are not dependent on the other variable. These values are chosen so that we call them our input. Okay? Because they do not depend on anything else. They are independent. Dependent variable, it depends on the input. We call this our output. What we put in is our independent. What we get out is our independent. Okay? Are you guys independent or dependent on your parents? Dependent. Dependent. You depend on them, right? They pay for your house. They pay for your food, right? You depend on them. Your parents are independent. Okay? They don't depend on anything. Right? So the input, the values that are chosen, is independent. Dependent, okay? That depends on the input. Any questions? Okay? Our independent, we also will call it the domain. We will call our dependent the range. Write this down. Functions are a relation in which each element of the domain is paired with exactly one element of the range. A function is only a function if each element of the domain is paired with only one of the range. So in the first question, is this a function? It gives you domain here, it gives you your range here. Okay, our input is 2, 4, 5, and 9. Our range is 1, 3, 4, and 7. Is this a function? Excuse me. Is each member of the domain only paired with one of the range? It is. What is 2 paired with? 1. What is 4 paired with? 5. What about 9? Okay. So they are only paired with one element of the range. So this is yes, it is a function. What about this next one? Is this a function? It is not a function. Because if you look, 2 is paired with what? 1 and 3. What's 5 paired with? 4. What's 9 paired with? 2 is paired with 1 and 3, so that means it's not a function. Alright, write this down. You don't need to write to determine whether each relation is a function. Just write like function with a question mark, explain, and then write these two down, the tables. This says determine whether each relation is a function, and then explain. Right? Now our domain is our x. Okay, our range is our y. Is this a function? Yes, because only one of our domain is paired with one of the range. Is 4 paired with anything but 6? Is 7 paired with anything but 10? What about 6? Is it paired with anything but 11? Is 3 paired with anything but 8? Okay, 5. Is it paired with 2 numbers? No. What about 2? No. So this is a function. What about this down here? Our x, this is our y. Okay. Why is it no? Okay, because 5 is paired with 1 and 5. Can we have that? Does it matter that our range, our 5, like our y here, is paired twice? Does that matter? No, it doesn't. Okay. Range can be paired with several of the numbers. Okay, as long as the domain is only paired with one number. And it'll make more sense here in a minute. All right, go ahead and write the definition of vertical line test and then draw a similar graph with dots. Okay, here's the definition for vertical line test. If the line passes through more than one point, it is not a function. So if I need to test if it's a function or not, and instead of giving me coordinates like all the other tables have done, this gives me dots. I can use the vertical line test. So what I do is I draw vertical lines. Those are lines that go up and down. Okay? And I draw it throughout the whole function, okay, to see if there's more than one dot on that line. So if I draw a vertical line right here, is there more than one dot on this line? There's only one dot right there, right? If I draw a vertical line here, how many dots? One. Vertical line here, how many dots? Vertical line here. Vertical line here. Two. There is more than one. That means this is not a function. Okay? Because there was two dots on one of the vertical lines, it means it's not a function. Okay, so let me erase all this. Let's talk about it. What are the coordinates of this dot right here? 5, 2. What are the coordinates here? 5, 6. How many times is 5 paired with a range? Twice. It's paired with 2. It's also paired with 6, isn't it? Does that pass our definition of function or fail it? It fail it. So what we do is we can just draw a vertical line to test it. Okay? So if you look at all the tables that we've been given, if you were to put those on a table or on a graph like this, a coordinate plane, the ones that said no, would they pass the vertical line test? No, they wouldn't. Okay, remember, I think it was the last one where it had 5, 1, and 5, 5. Remember that one? Would that pass the vertical line test? No. Write this down. This says that a function that is written as an equation, which this is a function that's written as an equation, can also be written in a form called function notation. Right? It's a fancy way of writing an equation. What's the only difference between this equation and this equation? Okay. fx has taken the place of what? Y. We still do it the same way. Right? Just think as this as your y. Okay, you plug in your x, which is your input. Remember your domain. You get what? Your range, which is your y coordinate. Okay, so if I put in a domain for x, I get my range. Right? There is no difference between these two, except that f of x has replaced y. Okay, so if you're supposed to graph the points, this is your x coordinate and this is your y coordinate. Alright, write all of this down. If f of x equals 4x minus 7, find each value. So this could have been written y equals 4x minus 7, but they wrote it in function notation instead. F of x, all this means is that the function with x as the variable, okay, is this, 4 times x minus 7. When they write f of 5, all they want is you replace x with 5. See how 5 is taking the place of x here? So I want to take the place of x here. So all I do is plug in 5 for x. 4 times 5 is 20. 20 minus 7 is 13. So the f of 5 is 13. Let's do f of negative 6. So I take negative 6 and put it where x was. 4 times negative 6 is negative 24 minus 7. So f of negative 6 is negative 31. So when they write it like this, 5 is my input, 13 is my output. 5 is my independent variable, 13 is my dependent variable. Okay, we only get 13 if you put in 5. We only get negative 31 if you put in negative 6. That's why this is your independent, this is your dependent. Okay, here's your assignment. The last two problems are going to be a little bit more difficult. They're going to be kind of like what's in the notes, except another step. But I don't want to talk about it. I want to see if you can get it. It's actual algebra. It's what my algebra students are doing when we do function notation. But I want to see if you can do it. I want to see if you can kind of think out of the box and figure it out. Okay, but don't spend a lot of time on it. Don't kill yourself if you don't get it right. Okay, just relax and just give it a good try.